Okay, so here we're back looking at just a super basic class. This is basically me just creating a new class using the add new item option here and in an UnrealScript file, and the infringe tool kind of auto generates this base class structure for you, defaulting the extension of the object class. Basically, everything in UnrealScript is an object that is core, that is like the lowest level base class, so to speak, that everything is in some way, form, or another derived from. But we talked about class structure just a little bit briefly when we were going over the overview file here when we first started kind of filling this out. But I wanted to come back to it just quickly because I wanted to talk a little bit more about class inheritance using the extends keyword in UnrealScript, and also just to revisit a few different things just to make sure that we covered kind of how the classes are set up and how those work before we start looking at what I want to do is kind of go over a couple of the somewhat commonly used UnrealScript files, or at least objects that you're commonly using in the editor when you're building levels, and kind of show you how the inheritances worked in those cases, how those files were structured very intentionally for the expandability of different object types if you want to add additional mesh types or different lights. And it's also good, as I was referencing earlier, also that just looking at the UnrealScript that has already been written, there's just thousands and thousands of lines of script here, and a lot of that you can pick up a lot just by looking at what's been done. Some of it too is very very complex and maybe a lot more in depth than anything you're wanting to mess with. There's a lot of functionality in UnrealScript that goes very deep and can go pretty low level. And you may be looking to just do more kind of modifications or adding a few new object types, but not really looking to do really heavy lifting stuff. And that's generally going to be fine because a lot of that stuff is already done for you with the stuff that's available kind of out of the box with UDK. And what hopefully you're going to be doing with this is maybe tweaking stuff, kind of modding what's there, tuning. I mean, you could come in here if you wanted and retune the weapons that are available, the different Unreal Tournament weapons, and make your rockets 100 times more powerful and just kind of play around with stuff. And it gives you a really good understanding of the relationship of objects and how that stuff all kind of works together, but you're not necessarily going to be getting in there and writing some super low level stuff. So again, just super basic here. We've got the class declaration, the name of the class. You have the extends keyword, which is specifying then what class you want to extend from. Everything, like I said, in Unreal is kind of derived from object. The other common class you'll see things derived from is actor. And if I switch over to this file right here, you can see they even have a kind of a unique comment here that says this is the base class of all actors, which is the base class of all gameplay objects. And this is really important. Basically, the actor class is what and you see it extends from object here, but the actor class is what gives those gameplay objects the core values or variables that they need to exist in the game world. If you scroll down here just a little bit and start to look at some of the member variables, you've got a vector, which is 3 coordinates, 4 location, rotation, scale. These are kind of the core things that all objects in the editor and the world need to have, and that's kind of apparent with the actor class. Of course, it has as you can see, it's a very large file. It's probably one of the biggest files in all of this code base, but that's because actor can cover a lot of things, and so they've put the stuff that's just really core to any object. Even if not all objects touch all of this stuff, obviously they wouldn't, but if they could, or some variation of an object will need to know this stuff, then it makes sense for it to be in that base class. The reason I wanted to show this, even though it's a huge file and it's a lot to take in, is it is really kind of pivotal to understand how the inheritance works, is that when you extend, so if we change this right now to be actor, so now this example class is extending actor, we have all of this. Everything in this file is now basically part of our object. It can be a bit overwhelming because there's a lot to kind of absorb here, but you now know, for instance, that your object right now, if you just compile this, even with no additional variables and no default properties, this is an object that, when placed in the game, would technically have, a location and a rotation and those core properties. Now, of course, it doesn't have anything to actually do anything with. An actor needs to have some sort of special implementation to kind of define any sort of usefulness. But the way the inheritance works, if you're not used to that from general programming like C++ or Java, basically this object now is an actor, but can have its own additional things. So anything you add in this class, we've gone over variables and enumerations. So if you're declaring variables in here, now this class has something unique that actor doesn't, and that is myInt. And in the default properties of this, you can set myInt to some default value, say 12. And so now any existent or placed version of this object of this class now has something unique. It has this variable that has the value 12. Of course, you have to do something with it, but it's kind of cool that you have this much power just by using a simple extends keyword. And then, just to make sure we've covered the structure, a lot of the stuff we did in the overview class actually is perfectly applicable to a class. You would be defining your functions, and maybe we're going to have this return, bool, and we're going to be doing our work in here. So all the stuff that we went over with functions, doing enumerations, the structure, all that stuff can become part of this class, and this class now has those variables and that functionality built into it. And if you were to write a new class that extended this class, then it would inherit all of the stuff that is in here and automatically have that, and then you could continue to add to it. We didn't really cover, I don't think, the default properties too much earlier when we were talking about variable declaration. Basically, this is kind of a unique thing to UnrealScript that I don't think you'll really see in any other programming like Java or anything like that. And in C++, you would just have the option to initialize the variable when you declare it to some value, but that's not valid in UnrealScript, and the default properties take the place of that. The best way to think of this is, in my mind, is like an init function. Whenever this object is placed or created, then the default properties kind of get called as part of the initialization of that object. And that way you're getting all these variables essentially initialized so that any work you're doing in functions that refers to this, if you've got it set in the default properties, then it's essentially initialized at creation, and you can safely do things with that variable. So this would be valid because this does have a value. This has the value of 12 by the time it gets to this function. So default properties, if you look at other classes, and we're going to get to that in just a sec, you'll see that a lot of the variables that are unique to either that class or in the case where it extends a base class. But if you've got, like, say, a single base class that two objects are derived from, and each of those objects does little to add new functionality or add new variables, but it's more just a different default state, then a lot of what they're going to have is just different default properties. But the actual work, and as far as new functions or new variables, may be limited or none. It's just a way for you to kind of set that default state. All right, so let's go ahead and bounce back over here to the actor file. Just going to kind of scroll through here and just highlight a few things that are good to know. Like, this is kind of going even beyond UnrealScript. This is just getting familiar with Unreal. If you've worked a lot with Unreal on the editor side, you've seen a lot of this stuff in properties. For physics objects, you've got the different phys states, and you'll notice that this is an enumeration, which we've covered, and it's a constant. They got the keyword in there saying, like, this is a constant, like, this does not change, and that's very important for the game to know, because this is in the actor base class, which every object nearly is going to derive from that. So you need to know that they're all going to have that same consistent enumeration, so that you can refer to that across all files. You've got more enumerations, and you've got a structure here, like we talked about structures. And the other thing that is kind of interesting here is if you as you scroll down, you'll start to see a lot of this, like the networking flags, and this is all dealing with replication for networked games. And there's just a lot of stuff here. And this is kind of where I was saying, like when we were talking about variables, like there's a lot of keywords. You'll see a lot of consts, but you've got things like transient and these just different kind of special isolated cases. And in a lot of cases, you're not going to need to deal with that if you're not dealing with networking or anything like that. It's all good stuff to know, but it's just a lot to take in and not really critical just to get the ball rolling. So, okay, so actor, like I said, is a huge, huge class. But if you look over here at static mesh actor, this is a good example of a static mesh actor, of a class that is gaining a lot of functionality based on inheritance. And, this class, though, is a lot smaller, right? Like, you got your default properties down here, and you got a couple of variables that are local to this, this class. You also see the CPP text identification here with the brackets. This is basically saying that these are functions that are actually written in C++, and this provides UnrealScript with an interface to call them. But you notice we don't actually see these functions. And with UDK, we don't have the CPP files available to us, so this is not something you can go edit or even in this case go look at. But it kind of gives you an idea of what functions are available to this object, even though you don't have the actual implementation. And the reason for having the implementation of functions be in C++ can be for different reasons. Sometimes it might just be scope of what that function needs to do and what it needs to manipulate is just not friendly to UnrealScript or not accessible or in scope, and there'd just be too much work to get that in scope, so it's better to write the function in C++. Another reason is performance. If there's a function that is doing a lot of work that is performance intensive, like a lot of ray casting, that stuff is going to be faster in C++ than UnrealScript, just pure performance of how it works. C++ is a very fast language. That's why it's used in games so prevalently, and UnrealScript is designed to be more about speed and iteration, but its performance is going to be less than CPP. So, but it going back to just the whole inheritance thing, it's interesting, I think, to see that a static mesh actor, which is so heavily used when building out worlds, has a pretty simple looking script file, but that's not that there's not anything to it. It just means that it's kind of stored elsewhere and it's just picked up a lot of functionality. So for instance, you notice that static mesh actor actually extends static mesh actor base. So it has its own base class instead of deriving directly from actor. So if we open up that base class, you'll see that this, again, is a pretty small file, but it extends from actor. And so really, with the exception of this one file that is actually written in C++, you basically got just a setting of default properties for the static mesh actor base, so that any new mesh actor class, so if you had, you wanted to create a new mesh class, you could derive it from static mesh actor base, and you would know that they would have basically a consistent default setting when you place that object in the editor. But you can then go and add your own additional things. In this case, it's adding its own static mesh component, which is going to give it that actual renderable object in the editor and in the game. So the static mesh actor base is very little, or a little more than just a default actor, which is not useful. Really, gives you that location, but it doesn't give you anything to draw in the editor to see or to manipulate. And so, just extending that class, which extends actor, and then adding this static mesh component, you've now got that renderable object. And static mesh component is a whole other, set of inherited objects that has a lot of stuff to it. But you don't really, need all that stuff. You just need your static mesh to have that renderable object. Another thing that is we'll look at is the trigger class. Triggers are obviously used a lot for scripting gameplay. Unreal has a few different trigger types. There's an actual trigger object which has like a cylindrical collision and is represented by a sprite in the editor. And then you also have like the line of sight triggers. And then you have the volumes, which are generated by the brushes like BSP. And you can do triggers off that. In this case, this is the placeable trigger that is, cylindrical collision. It's really cool to if you've worked on the editor side for any any amount of time and kind of familiar with the objects to then come and look at the files that generate those and see a lot of the stuff that you're maybe familiar with, and it's like, oh, that makes sense. That's why it's like that. For instance, you've got this trigger, and right here you've got an event called touch, which is looking for the sequence event touch objects, which are Kismet objects. And we'll get into those here in a second too. We're going to talk about those, but this is where, it's looking for that associated touch event in Kismet, or, in a sequence event that's been placed in Kismet that you're listening for essentially. And this is what's going to notify it that it's been triggered. And you've got the notify trigger function, and you see this a lot where, a simple event calls a function that may actually be defined in that same file, but you don't know where else you may need to call it from, and that's where it makes sense to kind of encapsulate it into a function. So, and then this one you'll also see kind of a large default properties. One thing that is worth highlighting here is default properties can do more than just set member variables. It can actually create objects. Like I said, it's more like an init function than maybe how default properties might read. So in this case, this trigger is going to have that sprite object in the editor. So when the trigger object is created, when a new object is created and the default properties are called or the init is called, you've got this begin object, and what that's doing is creating a new object, which is of class sprite component. And you see the different properties here. It's given it the texture to use as the actual sprite, and then it's adding it as a component to this trigger object. That's not the most clear thing, but basically this bit of script right here is what is giving you and defining that sprite that you can now see in the editor when you place the object and use to select it. And so if you wanted that to have a different sprite or a different icon, you can come in here and you can edit that. You also see that here is where it's defining, as I was saying, the trigger uses a cylinder for its collision. If you're not using the brush trigger type, just this object uses a cylinder collision, and you can see it's creating that cylinder component here, setting up its default values for radius and height, and then it's adding that component to this object as well. So there's this concept of components, and you can add as many as you want to the object. And those are based off of these different begin object and end object. So you'll see really a lot of the times the best way to learn this kind of stuff is when you want to add something new or alter something that is already existing, is especially in the case where you want to add something new, try to think of something, an object or an existing class that does something similar to what you're trying to do. We're going to go over some Kismet, how to create your own Kismet actions and events. And that's a really great example of most of the stuff you're going to do because of the kind of confined set of things that, an action or an event can do in Kismet as far as inputs, outputs, variable links, that's all pretty consistent. And so you can go look at existing classes and see, how they did something and copy and paste that or at least use it as a learning tool. And that's a really good way to just kind of pick up on stuff. And as you do it more and more, you'll start to build more of a mental map of where stuff is and how stuff relates and where some of the dependencies are. All right. So another thing real quick I wanted to show was, again, related to Kismet. You'll see the supported events. And this is another Kismet action. Anything that has a sequence, event, or action, or there's also a condition, that's kind of the naming convention to define Kismet classes. So this is adding support for that Kismet object. Here's the light class. I wanted to show this really quickly because this one does derive directly from Actor and does provide, some base functionality. Again, most of it is actually written in C++. You've got some stuff here for replication, which is for, that networked stuff. Here you've got function that's going to handle the toggle, which is a sequence action here. So you've got a passed in Kismet class here. The toggle is kind of a generic thing in Kismet, if you're not familiar with it, that can basically toggle the is enabled flag for just about any type of object that has a supporting flag. So you can call toggle on a light and it will turn the light on or off. You can call it on on a trigger, and it will turn off whether or not the trigger is active. So it's really just kind of a general purpose, and that's how they handle it. And then you've got your default properties. Again, same thing. It's adding a sprite here, which will be the editor object for that that light. How you select it, and see it, and then but not a lot going on. Not a lot of additional stuff besides what is in actor. But then you've got your specific light types like a spotlight, and you can see that derives from light. So you've got actor, and then you've got a light object which derives from actor, and then you've got a spotlight which derives from light. So it picks up all that toggle functionality and the different functions that we saw in there, but then it adds some of its own stuff that is going to be specific to a spotlight. And you can see that kind of clearly here with the different radius, inner cone, outer cone, stuff that only a spotlight needs to know about. And then also you've got the idea of the light component itself here, which is going to be new because of the different casting shadows and stuff like that. Also, you've got an arrow component. This is kind of a generic class that you can add as a component to any object. So you'll notice many objects or scripting objects that you place in the editor will have that arrow component indicating direction. This is how you add it. It's really simple. Again, this is a case where you're creating a new object and you know that you want to have an arrow indicator. It's very easy just to go find a class that has one as well and grab this as an example. All right, so kind of quickly jumping around there, but that's kind of going over how quickly you can go from actor to something like a static mesh or a trigger or a light or even a specific type of light. And that's all kind of just basically extension all from this keyword and that class hierarchy. Some things that will get a little confusing when you want to do something specific, like say you want to add a new weapon. You might want to make sure that you kind of do some looking around and take note of how the hierarchy of weapons is, because some of it may not be as clear or as straightforward as you might think. For instance, some weapons are considered instant hit weapons, which use a raycast to detect whether or not they load their target. And that's all done, in a single frame, whereas other weapons will fire projectiles, which are simulated and have an actual, duration and a life. So those weapons have kind of different paths of extension in the class hierarchy. And so it's just good to make sure that you kind of take in what's there, do some research, and make sure that when you're adding a new weapon, you're adding it in the most appropriate place. Because what that's going to do is if you're using the inheritance right, then you're going to minimize, well, in some cases it'll be the only way to do it, but you're also going to minimize the amount of work that you have to do in your class, because a lot of that functionality will already have been written for you. And so what you really need to do is just find that kind of right chain of inheritance and say, okay, I really want to inherit from or extend this class because it's already doing everything I want to do, with the exception of I want to change the particle effect and the amount of damage it does. If that's all you want to do, then you don't really need to do a lot of work. You can just find the object that's basically that same thing, extend it, override its default properties, and you've got a new weapon that does what you want, has maybe some slightly different tuning. Okay, so that's kind of a quick run through on classes. Next, we'll still talk about classes, but I wanted to talk a little bit about the Kismet stuff and how you can set that up, because Kismet's very powerful in knowing how to add or even just look at what is there. I know when I was learning Kismet, there was a lot of unanswered questions for me as far as like what was valid or how this was intended to work. And looking at the UnrealScript was a great way for me to kind of understand that and, kind of educate myself on the Kismet side of what can do what and what's better suited for certain applications.